Welcome back to computer programming. This is Mr. Fractal. Today we're going to look at one more example of recursion and drawing fractals with recursive algorithms. The one we're doing today I think is pretty neat. It's drawing a recursive tree. It looks kind of like a tree. And I'll start by showing a version that was done in processing. This is very similar to what we'll be doing today using turtle graphics. In this particular one, it's interactive. And so as I slide my cursor across the window, you'll watch as the tree gradually unfolds, which I think is a really kind of pretty effect here. So I can make my tree unfold. Now, hopefully you can see how this is a recursive algorithm in that we've got a trunk down at the bottom. It goes up, it branches into two pieces, and then each of those branch into two pieces, and each of those branch. Each time you're drawing a smaller tree. So you could look at any one part of this and say, oh, that's a tree, right? And so you go up with the trunk, and then you turn one direction, draw a tree, then you turn the other direction, you draw a tree. And each time you're just drawing smaller trees. So that's that example of recursion where there's this smaller and smaller sub-pieces that get built on using that same algorithm. So again, ours, the one we build today won't be interactive because we're just going to use turtle graphics to do it, since we already know how to use turtle graphics for that purpose. Okay, so let's go look at, this is similar to the problem that was given in the problem set 14. One of the optional problems is Fractal 2. And in Fractal 2, they show 3 different iterations. Kind of your base case here is where you just have that trunk. When n equals 0, you just go up and that's it. The n equals 1 case, you go up the trunk and you turn to the left and you draw a branch, and then you turn to the right and you draw a branch. And then in the n equals 2 case, you go up the trunk and you draw a branch, but that branch is really a whole tree. It's that iteration, it's that previous iteration. So you go up the trunk and you turn to the left and you draw this iteration from n equals 1. And then you turn to the right and you draw this iteration from n equals 2, right? So we can again see that recursive action happening there. We're going to be using this method called tree here. And in this method tree, what you see is we've got these 4 parameters. N here is the recursive level, kind of the number of the iteration that we're doing. Len is just the length that you want that original trunk or branch or whatever to be. And then the angle, so like in this case, we're going 45 degrees. So we got the trunk, we turn 45 degrees to make that first branch. And then we have to go back to center and another 45 degrees to the right to get the next one. And finally, we'll send in the pen. Okay, so let's switch over to IntelliJ and we'll start writing the code for this. So I've got a Fractal tree class. In here, I'll make my main method. And I want to make a sketchpad window. And I'll just call that window. And we will send into that the width and height of our window. And you know, right now, IntelliJ is complaining because I haven't imported turtle graphics and so forth. So let me just go up and just import turtle graphics in here. And I'll just say get everything from turtle graphics. We'll just be using the sketchpad window and also the pen, the standard pen. Let me define my values for width and height. We'll make it 600 wide, or 500 wide should be plenty. And we'll make it 600 tall. Okay. We've got our sketchpad window. That looks good. We can just verify that things are drawing the way we want them to. So we'll just move our pen and see, I got to make my pen. And we'll send that window in as an argument to the pen. So that pen will draw in the window we just created. And now we can try moving that pen and seeing if that's what we like. Okay. And we'll just double check everything's working here. Yeah, there we go. There's our sketchpad, and we're drawing from position 0, 0 right now. So it might be nice if this is going to be the base of our tree to move this thing down. So let me start at a point which is lower down than 0, 0. So before I actually move my pen here, I'll say, let's lift the pen up so it doesn't draw when we move it down. We'll then move it down a ways to a new location. And so I'll say still centered horizontally, but we'll go down like 200. Okay, and then we can put our pen down so we're ready to draw. And let's see if that looks like a better trunk for our initial part. Whoop, I guess that's right. So it's starting in an okay place, but it's drawing in a downwards direction. So we need to go and set that initial direction to be upwards here. So let's see, lift up our pen, we move it down. So let's go and we'll say pen.set direction. And we'll set it to 90, which is facing straight up. Like that. I always think it's valuable just to test simple cases along the way, just to make sure things are working as we think they should. There we go. So that could be a trunk for our original tree. That looks fine. Okay, so now it's time to go and write that tree method here. Void method is doing nothing but drawing. It doesn't have to return anything. And we're going to give it these 4 parameters. The first one, n, was the level of the recursion, that kind of iteration number. The second one was the length, how long we want that first trunk to be. And the next one is the angle. How much do you want it to bend? And finally, we send it a pen. Okay, and I think I did those in the right order. Let me just go check our homework assignment and see what we said there. So yeah, length, angle, and pen. So that's just that same method signature there that we're using as our method header. Okay, we want to think about this recursively. Remember, we'll need a base case, and so that looks like n equals 0. So we'll start there. And we know in that simplest case, we just want to draw that line. And so we'll say pen.move, and the distance it should move is just len. We're telling it how long that trunk should be. Okay. In other cases, we need to think more carefully about how we're going to draw that tree. And so let's just turn and look at our whiteboard for a minute and see if we can figure out what should happen. I'm going to go back and kind of compare this to our homework assignment. So we've got the homework assignment here, and let's just look at what we want to do as we go from one iteration to the next. Okay, so what I'm imagining is, we'll just look at this on the whiteboard for a moment. Make this a little bit larger here. So what I'm imagining is that we want this tree to start in some place, and we need to go up some distance, right? We're then going to need to turn some angle. So here we've got an angle. That angle there, that angle was given. And then we want to draw this branch, and then we want to come back down the branch, right? So we move our turtle up the branch to draw it. We come back down the branch. Now we want to turn this other direction, which means we're going to have to move that angle, and then that angle again to the right in order to get this new direction for the next branch. Okay, so let's see if I can get code that will do that. We'll go up the trunk, we'll turn some angle, go up the branch, go back down the branch, turn the other way. It has to have to turn twice as much now because we were facing this way. We're going to have to go twice as much the other way in order to get back. Okay, let's see if we can do that. So we're going to go up the trunk. So we'll say pen.move. We now want to turn, and we're going to turn whatever angle was given to us. And that's got, the pen has to turn that. We're now going to draw this branch, which is going to be shorter than the original branch. And it's up to you how long. I'll make it like 2/3. That kind of comes out looking pretty nice. So 2 times the length divided by 3. So 2/3 the original length is how far we'll move it. Okay, so we're drawing the trunk first. Let me kind of comment as I'm writing this. Okay. We now want to draw the left branching. Okay, so we turn our angle and we move out that distance. We now want to do the right branching, but we can't do it from where we are. We have to retreat back down this branch before we can draw the next branch, right? We have to get back down to that junction, right? So in order to get back down this branch, I'm gonna have to turn a 180-degree angle and move back down it. And so let's do that. I'll say we'll turn 180 degrees. So I'm gonna head back down the branch. And then once I've gone down to the end of the branch, actually I need to move. Again, we'll go 2 times len over 3. So I've turned, I've gone down the branch, and now I'm going to turn to face back up it again. Okay, so that's all that was involved in drawing that left branching, right? So I turn an angle, I move up the branch, then I turn back around to get down to the bottom of the branch I just drew. I move back down that length, and I turn myself so I'm facing up the branch again. I'm now ready to draw the right branching. And so I need to turn. I'm facing towards the left branching, so I need to turn to the right by twice the angle. So I'll say, I'll go 2 times the angle, but I want to do it in the negative direction. So I'll say -2 times angle. And then I'll go out and draw a length of 2 times len over 3. Okay. So I draw the trunk, I draw the left branching, I turn twice the angle the other way, I draw the right branching. Let's go and just see how this is doing here. Okay. So we'll run our code. Oh, so that's for n equals, I haven't changed my call yet. Instead of moving the pen 150, what I want to do here, we're ready to draw at this point. I'm going to go and I'm going to call my tree method. And so I'll send the iteration number. Let's just check each iteration. So we'll double check that 0 iteration works. The length I'll say is 150. The angle I'll make 45. I'm sorry. Yeah, that's right, 45. And finally, the pen I'll send in. Okay, let's see how that looks for the 0th iteration. That should just be the trunk of the tree. Pretty basic. Let's go see if it did okay for the n equals 1 iteration. That looks pretty good also. So it's going up the trunk, right, up len. It turns by 45 degrees. It goes out the left branch, right? It now turns around and goes to 180 degrees to go back down this branch, right? And so that's where, again, in our code, we're going back down the branch here, okay? Go down 2/3 of the length. We then turn 180 degrees, so we're facing up this branch. We're down at this junction, but we're facing up the left branch. It's now time to turn to the right. And so we turn to the right by 2 times the angle, and then we can go and out that length. That looks pretty good. So this code seems to work, but of course, it's not recursive. I've only got 2 possibilities here. Either n is equal 0 or it's anything higher. So if I do anything bigger than n equals 1, I still get the same result. And so that's not quite what we want. The next step is really to make this into recursive code. So here it is for n equals 2. No surprise, it's exactly the same thing as we got for n equals 1. Okay, so our job now is really to change our else statement so that instead of just saying, here's how to draw a tree for a given value of n, like n equals 1, we want to make this written in terms of the previous one. We want to have a call so that if you call n equals 2, this is somehow doing something in terms of n equals 1, which does something in terms of n equals 0. Hopefully you've already watched the Cook curve video that I made, and if so, then you might recognize what you want to do. So I'd encourage you at this moment, I'm going to go ahead and stop the video, and I'd like you to try and make the changes you need to make in this else statement so that our else is referring to, it has a recursive call. It's actually calling this tree method for n minus 1. Okay, don't spend a huge amount of time. There's still a lot of challenges involved in this problem, but go ahead and take a few minutes and play around with modifying this to get the recursive calls in it. Okay, and then I'll be back with the next video.